In this video, we'll talk about local extrema. And by local extrema, I don't mean your neighborhood ninja kitty terrorist. Nope, I just mean local extrema. So what's a local extrema? Well, we may have a situation like this where we have a graph. It indicates your energy level throughout the day. So the y-axis indicates how much energy you have. The x-axis, we have the time of day, 7 a.m. all the way through noon, through 6 p.m. till 9 p.m. So when you wake up at 7, your energy level's kind of low, and then you start eating breakfast, you get ready for the day, and then you're starting to move. Maybe your energy level, like mine, starts to peak out at about 11 a.m. This would be an example of a local extremum. This would be in particular a local maximum in your energy level. And then as the day moves on, you have a siesta in the afternoon, you get a little tired, and then at about 3, you get your daily espresso, and you get jump started. Your energy level picks up with the help of a little caffeine, and then your energy level picks up, and maybe it starts to peak out at maybe, say, 5:30. This would be another local maximum. But in between these two local maxima, we have this local minimum. That's where you have this nadir in your energy level. It's the lowest energy level nearby. Okay, so these are 3 important points. They're examples of critical points. So here's a place where the derivative is 0. Here's another place where the derivative of the function is 0. The slope is 0. Now this other point, this local minimum, actually it's not a place where the derivative is defined at all. You might think the derivative is this, and you might think the derivative is that, because those are both tangent lines, but there's no unique tangent line. So in fact, the derivative doesn't even exist. Okay, in any case, all 3 of these points are very important, and we have a word for them. It's critical point. So what's a critical point? Well, if f prime of x is equal to 0, so the slope is equal to 0, or the derivative does not exist, then x is called a critical point. Now we also call x comma f of x a critical point. And the f of x is called the critical value. Okay, so this is a definition you definitely want to remember of critical points. Now in the previous example of this energy function, I have critical points here, here, because f prime doesn't exist, and here, because f prime is 0. So those are my 3 critical points. Notice all these are relative or local extrema. The critical values are the value along the y-axis. So whatever this height is, that'll be the critical value at this associated with that critical point. The other critical value will be the height associated here, and the critical value here will be the height associated there. Okay, so those are your 3 critical values associated to your 3 critical points. Now, critical points are candidates for local extrema. That is, if we're trying to find a local max or a local min, then we should be looking for critical points. That's one thing to look for, and these are going to be candidates. Now, what's not true is that every critical point gives you a local extremum. They're just candidates. It's kind of like, you know, just because people are candidates for a party doesn't mean they're actually going to win the election. We'll have to see. So for example, here is an example of a function, the graph of a function. This is clearly a critical point because the derivative is 0. Here's a critical point. The derivative is 0. Well, here's also a critical point because here the derivative is 0. So f prime of x is equal to 0 at each one of these places. So they're all critical points. All three of these points are critical points. But not all of them are extrema. This one it's a local minimum. This one is a local maximum. It's a peak. But here, well, to the left of this point, the function is larger, and to the right, it's smaller. This is simply a plateau. It's neither a max nor a min. To the left, it's smaller than anything to the left, and it's larger to anything to the right. A local max is characterized by on both sides, it's the largest point. It's the top of the hill. And then a local min is the bottom of the valley. This point is more like a plateau. And a plateau is neither a local max or a local min. So this is not an extremum point. Okay, so in the future videos, we'll see how to figure out when you have a critical point and to classify them as maxes, mins, or neither.